All right, I'm live again. Good afternoon, everybody. So, I thought we are going to do discrete maths. Right. I am kind of liking these sessions now, to be honest. Okay, cool. Okay, it's not previous years, it's subjects. Engineering mathematics, discrete mathematics. Okay, let's solve this. What's not previous gate. This should work out. Okay. So is this long enough already? I think it is. Let us, you know, go that side a little. So my aim is to complete 60 questions of discrete mathematics this session, and then we will get other things done. Yeah, we have done this. Arbitrary predicate over the domain of natural numbers, which one of the following statements is true? P of 0 is true, and for all x, P of x implies P of x plus 1 for all P of x. For all P of x, this is true, and if x is true, x plus 1 is true. Right. This won't be true. This won't be true as well. Alright. For all natural numbers, it is asking, so A is correct answer. We have done this question before. Let f be set of functions from 1 to n to 0, 1. Define the binary function on f as follows for all f of g, if and only if for all x 1 to n, f of x is less than or equal to f of g, if 0 is less than or equal to 1. So the following statement is true. I see. So f is the set of functions. Okay, so f of x is less than or equal to g of x. Right, for all f comma z belongs to f. Right, this is the actual definition. So the symbol is what we think it is. It's a symmetrical relation. That means if f is less than or equal to g, g is less than or equal to f, that is false, so it is not symmetric. Partial order. Right. That is not symmetric. Equivalence is when f is reflexive, symmetric. Reflexive, anti-symmetric, and transitive, right? So it is not equivalence as well. Is it a partial order or is it a lattice? All right, so we have studied between partial order and lattice. What is a partial order? Binary relation, reflexive, huh? Okay, opposite is RAT. What is equivalence relation then? Equivalence relation. Reflexive, alright. Reflexive, symmetric, and transitive is equivalence. Reflexive, antisymmetric, transitive is opposite. Partial order relation. What is a lattice? greatest upper bound and least upper bound and greatest lower bound as join and meet. As join and meet. Okay. If it is a lattice, there are GUB. Alright. Is it a lattice? Let's see. Let's break down this problem. Which function can be thought of with a strings of length? Bit string. Bit string. That is a good intuition, actually. Bitwise comparison. Nice, man. 0 is less than or equal to 1, less than or equal to 0. Symmetric. Okay. And asymmetric. Transitive. Meet. Okay, this is 0, 0, 1 is the meet. And alright. He gave like an intuition and a sense of what could be. We got the answer, but we were never able to do that big of an explanation. Surjective function. There is good explanation for this as well. G of G must be surjective. Okay. F is surjective onto and f of g. Okay, this is onto as well. These two are onto. Okay, function g of x. I mean, this exists, and for everything, I did something for this one. Nice. The comparison of two functions is one. Composition, yeah. The second function must be onto. Let's see. Every element in set C is okay. Okay. We got a problem with this one. Okay, I cannot understand what's going on over here. Yeah. Right. Okay. Yeah, this guy messed up again. It is ambiguous, right? So G of F that is f of g. Since we do the inner things first, g maps from A to B and f maps from B to C. This, and this. We were told this is onto. So the codomain is the range. This is the condition. And is it necessary that this should be a 1 1? No, this can work like this as well, right? Why? Because maybe g of 10 is not right. Let's do this. G of anything is equals to 1. Let's do this. And f of 0 is equals to 1, f of 1. Right. Then f of g is, right, f of g of 10, or g of r, right. It is a separate function. Okay, if you have a good idea of this, then if you have a good idea of domain, range, and codomain, then we're good. The second function. So we're still having a doubt. So there is nothing needed about g of x because everything this can handle out. This is not 1 1, this is not onto as well. Okay. Composition of functions. Let us be the set of all ternary strings defined over alphabet ABC. It contains at least one occurrence of 2.0 resemblance. String of length 5 that are possible. A. Right, there are three choices. If you do something like this too, it will be covered. 27 times 3. 81. I don't know. We solved this already. Total possibilities minus no two alphabets of same occurrence. Are we even close? Okay. If you do something like this, you might get a here and a here as well. So there will be mix-ups, and you might get. So this is not the correct approach of thinking in combinations. You might get a b, and you might get um, yeah. So there are similarities and there are differences between these two. So 33333, that's 81 threes, 243 total occurrences, and alright, no two occurrences are same. So you can either place A or B or C here. If you place A here, we have even did this analysis. You cannot place A here, so you can place either B or C here. If you place B here, let's say, you can place A or C here. So three ways, two ways, two ways, two ways, and two ways. Alright, 16, 48, 5, 195. Okay, got it. Complementing. With time and understanding, everything becomes clear. Let's see. I really hope that to be the case because I do not have anything else. We did this problem as well, so we should be able to do this. Mother y of x means y is mother of x. X and y are not equal. Everyone has exactly one mother. Okay, alright. Let's write it in mathematical. Alright. If y is mother of x, no, y is mother of x and z is not mother of x. For all x, there exists y and z. Yeah, but it is not saying anything about unique. Like you can still have one mother. I mean, two mothers and a person who is not mother, according to this. For all x, there exists y. Y is mother of x, and for all z, z not equal to y implies z is not mother. So if anyone is not my mother, then they are not my mother. That's what he is saying. There exists y. Yeah, B should be answer, but let's check out other things as well. Y is mother of x. If y is mother of x, implies z. Z is mother of x. Okay, if y is mother of x implies there exists z. There exists z, that is mother of x. Z is not equal to y. Basically saying two mothers. So that is not it as well. Y is mother of x and there does not exist, there is no Z, there is no Z such that Z and Y are not equal and Z is mother of X. So what he is saying is Z is not equal to Y and Z is mother of X. There is no Z like that. Z is not equal to Y means different, different and mother. No one like that. So what is about B? For all X, there exists a Y. Y is mother of X, and for all Z, for all Z, Z is mother of Y. If Z is mother of Y, that implies, okay, if Z is not equal to Y, for all Z, if Z is not equal to Y, that implies Z is not mother of X. Correct representations. This is a multiple choice. B and D. Okay, we did it. We are correct. Why did I freak out? We are correct. You need to check if the answers are single correct or multiple correct as well. Okay. A is a set of non-negative integers. Okay. F is a set of functions from A to itself. Okay, we did this one. We did this one as well. What is a Abelian group? We did this, man. Okay, I mean, with just solving one question, you cannot remember that. I see. There is something about inverse existing of identity and all. All right. Okay. Alex. All right, people. Guess I need to sleep for some time. Yeah, I guess.